we've made the transition from problems involving constant velocity, where we would use this equation, otherwise known as our group A equation, to problems involving acceleration, where the object is speeding up or slowing down. When the object accelerates, we're going to use one of these equations, our group B equations. A is equal to delta V over delta T. VIT plus 1/2 AT squared. If you take a look at your data sheet as I'm writing these, you'll find all of these in the top section under kinematics of your data sheet. If you don't have the first one circled and labeled as a group A equation, then you should do that now. And if you don't have the second group, this green group, labeled as group B equations, you should do that now. Whenever we see a problem involving acceleration, like we did for homework last night on page 48, we know right away that we've got to check our group B equations. Now, which one do we try within our group B equations? Generally, there's one equation that's going to work better than the rest of them. And if you find that right away, that's great. It might save you some time and it might save you some effort. But if you don't spot that right away, that's okay. As long as you don't see a group B problem like you're going to see in both of these practice problems that you worked on last night, and try the first equation, delta D over delta T. That's the one no-no. Try anything within the group B's, and the worst that's going to happen is you're going to have two unknowns, or you're going to solve for something you're not looking for, but you're not going to get a wrong answer. Remember that. Don't panic about it if you can't figure out which equation to use. As long as you pick from the right group, you should at least, at the very least, not get a wrong answer. And if you don't happen to get the right answer, then just try again. Try something else. All right, let's take a look at those homework questions that we had last night, page 48. Either of those you'd like to go over here, one or two? Yep, number two, okay, perfect. Number two says a ball moves up a hill with an initial velocity of 3 meters per second. 4 seconds later, it's moving down the hill at 9 meters per second. What's the displacement of the ball from the initial point of release? Clearly, this ball is accelerating, right? It's changing speed, it's changing velocity, it's accelerating. It's a group B problem. Let's erase my group A equation here because we know that we're going to pick from our group B equations. And now let's figure out, now that we know it's a group B problem, now that we know it's one of these equations, let's figure out what our givens are. Something is 3 meters per second. Can you tell me what that is? Yep. Good, that's VI. That's how fast you're moving at the beginning of the problem. Something is 9 meters per second. Tell me what that is? VF. We're looking for the displacement, right? Oh, we got a time as well, 4 seconds. And we're looking for the displacement. Good? Nobody wants to challenge me on what I have written down there? Shredda? Good. VF should be negative 9.0 meters per second. Typically, we're going to define up the hill as positive at least, and then that should be negative 9.0. Now, if you happen to, for whatever reason, define down as positive, that would be okay, but the 3 would have to be negative in that case. Good. Okay, don't accept what I say. Okay, look at it critically and tell me if I've made a mistake. Sometimes I make the mistake on purpose, sometimes I don't, but tell me. Okay, don't be afraid to challenge what I've said. Okay. What do you want to do here? Delta D we're looking for. What equation out of our group B's do you want to try? Hey, just actually, let's do one quick little aside for a second before you answer that question. When I look at this, I see VI 3, VF is 9, T is 4, D. It almost looks like I should use V equals D over T, right? Just maybe subtract the velocities, use distance over time. I can't do that though. Even if it looks like it fits the givens, don't do that because it's an acceleration problem and you can't use a group A equation with an acceleration problem. So we've got to use, whether we like it or not, we've got to use one of these ones in green here in our group B list. Which one do you want to try? Oliver? Yep, over 2 times T? We can absolutely try that. Now, I think that's a good choice, Oliver. Having said that, there's not really a bad choice. As long as you pick from within group B, they're all valid. I would have said good choice for any of those equations within group B. Now, I think that's a particularly good choice because it's going to work for us right away. We're not going to have to find something else or try something else or whatever. And if you spot that right away, that's great. But if you don't, let's say you try D is equal to VFT minus 1 FAT squared first, that's okay. That's okay. Okay, worst case scenario, you get an answer for something you're not solving for, or you have two unknowns, no big deal. All right, let's plug in some numbers here and see what happens. VI is 3, VF is negative 9 over 2 times the time interval of 4 seconds. And when you do the math, I think you end up getting negative 12 meters. Now, I'm not sure what the distance is here. The displacement is negative 12. I'm not sure what the distance is, but I can tell you that the distance would not be negative 12. How do we know that? Yep. Good. It was initially traveling up and then it's coming down, so it changed direction. Remember, distance and displacement have the same value, just displacement has a direction if it keeps going in one direction, right? If it was going down the hill the whole time, distance and displacement would be the same number. Up the hill the whole time, same deal. But if you're changing direction, distance and displacement, two different numbers. Again, don't know what it would be, but it's not going to be negative 12. Your first hint, I guess, is that it's not going to be negative anything, right? Distance is always a positive value. You guys okay with that question? All right, let's try another one then, page 50. This one says a golf ball that's initially traveling at 25 hits a sand trap, slows down with an acceleration of negative 20. What's its displacement after 20 seconds? I like this question. I like this question because it kind of leads some of us into making a little bit of a mistake. It's a group B problem, right? Because it's accelerating. It's slowing down, actually. We're going to say VI is 25 meters per second. We're going to say A is neg 20, means it's slowing down. And we're going to say the time interval is 2.0 seconds. Is there anything else that I have given to me here if I read between the lines? Anything that is kind of told to me, but I don't have it written down right now? VF is equal to 0. How many people agree with that? Okay, lots of people. Where does it say that? Where does it say VF is equal to 0? Ethan? Okay, yeah, it's a sand trap and it slows down.
It doesn't really say what to.
No, it doesn't say what to. It doesn't say it slows down to stop. It doesn't say it slows down to rest. Okay, it says slows down. Now, eventually it will stop, right? But it may take 3 seconds to stop or 4 seconds to stop. The question here is how fast is it moving after 2 seconds? It may, in fact, stop after 2 seconds, but they don't tell us that. Does that make sense? So we're not going to say VF is equal to 0. That's the mistake that everybody makes on that question. And that's why I like that question so much, is because it helps, hopefully at least, clear that up. Why sometimes we can assume VF is equal to 0, and why sometimes we can't assume that. All right, we're looking for the displacement here, so let's write that down as our unknown. What do you want to try? One of our group B equations, right, Matt? Which one do you want to do? That looks like it's going to work, but you know what? Even if it doesn't, it's no big deal. It just means we try something else, right? Let's give it a whirl and see what happens here. VI is 25 meters per second. Delta T is 2 seconds plus 1/2 of, well, you got to be careful with this. Neg 20 is the acceleration times T 2.0 squared. 25 times 2 is 50. 2 squared is 4 times 20 is 80 times 1/2 is 40, but it's negative, because it's 1/2 times negative 20. 50 plus negative 40 gives me 10 meters. Okay, that works. I used a valid equation, I got an answer, and it's the answer for the variable that I'm looking for. So unless I made some silly mistake somewhere, I've got the right answer here. Now, a quick question for you, just kind of a follow-up to the question I asked you in the last problem we did. Would the distance be the same value as the displacement here? We're not asked to solve for the distance, and we won't calculate its value if it's not the same value, but would it be 10 meters? Yep. Yeah, it would. Yeah, because it's not changing direction, right? As long as it goes in the same direction, distance to displacement will be the same value. All right, let's try those two questions to go with it on page 50, please. Okay, we're going to take a look at question number 2. It says a motorcycle traveling at 100 kilometers per hour on a flat road applies the brakes 0.8 meters per second squared for 1 minute. How far did the motorcycle travel during this time? This is a group B problem. It's decelerating. The motorcycle is slowing down. Let's write down some givens now for question number 2. We know that VI is 100 kilometers per hour. We know that we're going to want to convert that to meters per second. Let's just do it now. Okay, we know we got to do it. Let's just do it now. 100 kilometers is 100,000 meters. So we're converting the top first. 100,000 meters is 100 kilometers. Then let's convert the bottom. 1 hour is equal to 3,600 seconds. So convert the top 100 to 100,000, convert the bottom 1 to 3,600. Gives me 27.778 meters per second. We've got a time interval of 60 seconds. 1 minute, which we got to convert that to seconds, right? So I'll just do it right now again, 60 seconds. The acceleration is 0.80 meters per second squared, right? And we're looking for the displacement. How far did it travel? Is that right? You guys agree with me on everything there? What's wrong? Yeah, that's why I left a little space there, right? Why is it a negative 0.80 meters per second squared? It's slowing down, right? They don't tell you that it's negative 0.8, but they kind of do. It applies the brakes, which means it slows down, which means it's got to be a deceleration, a negative acceleration. All right. Let's try, I think D is equal to VIT plus 1 half AT squared. We'll try it. If it doesn't work for me, then we'll try something else. No big one. VI is 27.777 times 60 seconds. All right, let's do this one on the calculator so we can make sure we get the right answer here. 27.7778 times 60. Let's write that number down. 1666. Now let's figure out what's on the right-hand side there. 0.5 times negative 0.8 times 60 squared. Hit the little x to the 2 button. 60 squared gives me negative 1440. Well, now we can add these together. And we get 226.7 or 227 meters. Oh, they have it rounded to 2 digits. I'll explain why later on. That's not for us right now. But rounded to 2 digits, that would be 2.3 times 10 to the 2 meters. Okay? Big key there was the negative acceleration, right? They're not going to tell us that, right? They're not going to write that down. The acceleration is negative 0.8. They expect us to recognize that when it's slowing down, that it's got to be a negative value. All right, let's try another one. Thank goodness for the picture here, hey? Couldn't possibly understand this question without the picture. A speedboat slows down at a rate of 5 meters per second squared, comes to a stop. If the process took 15 seconds, what's the displacement of the boat? Well, it's a group B problem, right? Because it's slowing down. What do we got given to us? Acceleration is 5 meters per second squared. The time is 15 seconds. Looking for the displacement. Anything else we have given to us? What's VF? Yeah, VF is 0 this time. In that golf ball problem, it wasn't 0 because they didn't tell us, right? It slowed down, but they didn't tell us if it actually came to a stop within the frame of the question. Here it does. It comes to a stop. So VF is equal to 0 meters per second. Anything else here that I'm missing? Good. The acceleration is -5 because it's slowing down. Which one do you want to try? I'm thinking VFT minus 1/2 AT squared. Let's give that a whirl here. VF is 0. Why did I cross that off? Why did I cross that off? VF is 0, but Cody? Yeah, good. Anything times 0 is 0. This is going to be 0, right? VF times 0 is 0. Sorry, VF times 15 is 0 because VF is 0. Subtract 1/2 of -5. Negative is important there. Times t squared, 15 squared. What do we get? 0 minus 15 squared is 225. 225 times 5 is 1125 divided by 2 is 562.5. Negative 562.5 because it's subtract the negative value, right? Which, of course, if you subtract the negative value, what do you get? Positive value. So the answer would be positive 562.5 meters. And really, it should be a positive number, right? Which way is the boat going? In the positive direction. The displacement should be a positive value. Even though it's slowing down, the displacement should be positive because you're not going in the opposite direction when you're slowing down. 562.5. We saw a little issue with significant figures in the last question. We're not going to worry too much about significant figures, but I'm going to point something out to you right now, okay? How many people have done significant figures, by the way? Oh, you guys are laughing. We have to know where to round our answers to. We round our answers not according to 1 decimal place or 2 decimal places, but according to the correct number of significant figures. We round it to a certain number of significant figures because basically we're saying, look, if our question has data that's not very precise, then our answer shouldn't be very precise. Make sense? We can't be any more confident of our answer than we are the data that goes into it. Okay, another expression sometimes we use along with it, you know, you've heard the expression, a chain is only as strong as its weakest link, right? If our weakest piece of data is 2 digits, then our answer can only be 2 digits because the answer can only be as strong as its weakest piece of data. So when we look at our data here, we had 2 digits, our final answer should be, well, what's the weakest piece of data there? 2 digits. Our final answer should be 2 digits there, right? The only way to make that 2 digits is to put it in scientific notation. 5.6 times 10 to the 2. See that? Not counting this, right? We're just counting this. 2 digits, final answer, because we had 2 digits in our data. Start thinking about that, but don't panic about it. You're not losing marks for a while for significant figures. Okay, we'll start talking from time to time about what it should be rounded to, and by the end of Unit 1, I'll expect that you get it, and then I'll start taking marks off after our Unit 1 test. Okay, let's try those questions at your desks, please, page 51. All right, we're going to have a quick look at question number 1. It says, if the arresting device on an aircraft carrier stops a plane at 150 meters with an acceleration of -15, what's the time that it takes the plane to stop? Looks like we're going to have to finish it up tomorrow, okay?